Hello friends, welcome to the channel Base Your Btech. So today I have come up with an interesting and important chapter from engineering mathematics, that is vector calculus or vector analysis. This video is a very basic lesson for the chapter vectors. Why? Because I start with defining a vector. Also I will help you to picturize a vector followed by vector addition, multiplication, dot product, cross product, etc. Also this video will be very helpful to those who look forward to study the other subject, other topic from multivariable calculus like multiple integrals, partial differentiation, etc. So let's get into the video. See, we live in a 3D world. So how to spot out a point in this 3D world or a 3D space? For that, we require 3 dimensions, which we call it as 3 axes. That is x-axis, y-axis and z-axis. And all these lines meet at the origin. Okay. Actually, this system, XYZ system, is called as Cartesian coordinate system. So how to represent a point in terms of this Cartesian coordinates? Here I have brought one point which is P. Okay, how to represent this point in this Cartesian coordinate system? For that, I need to draw a line parallel to z-axis from there, this point. Okay, this line crosses at xy plane, and from this point I produce two another lines, one parallel to x-axis and another parallel to y-axis. And you know this line touches x-axis at, let it be 2 here, and in y-axis let it be 3, and on z-axis the point is, for that I need to draw a line perpendicular to z-axis, so let it be 4. So now I can represent this point P in terms of xyz coordinate system, that is 2, 3, 4, x coordinate, y coordinate and z coordinate. So this point P, as of now, it has got no direction, isn't it? No direction is indicated by this simple representation 2, 3, 4. So how to represent the same point along with its direction? And there we have the context vector. Okay, what is a vector? Vector is a quantity that requires both its magnitude and its direction. So how to represent a vector, or what is a vector? How can we picturize it? For that, I again produce one Cartesian coordinate system, x, y, z, and the same letter P. Now, in order to indicate the direction of this point P, I need to draw an arrow connecting from origin to this point P. Here goes one arrow starting from O to P, and we call it as vector OP. And how do we write it? OP with an arrow above it. Okay, so this is vector OP, even can be written like simple vector P is equal to 2i cap plus 3j cap plus 4k cap. Actually this I cap, j cap, k cap represents the direction. See, 2 units along this x direction, 3 units along y direction and 4 units along z direction. So it is simply 2i cap, 3j cap plus 4k cap. I cap is the, actually we have to specify one thing, that is it is the unit vector along x-axis, and j cap is unit vector along y-axis. Lastly, k cap is unit vector along z-axis. Got it? Now what is this unit vector all about? So let's see to it. So this unit vector is also called as direction vector. Direction vector. As I said, for a vector, we have both its magnitude and its direction. Okay, magnitude and its direction. So take an example for the same vector, vector P. We have got its magnitude, and magnitude is represented by the vector P inside modulus. And direction means it is simply a cap written above this letter P. So this part is called as magnitude of P and this is called as direction vector or unit vector of P. Now how to find this magnitude of a vector? It is simple, root of the coefficient or the number written along with I cap, that is 2 square, plus number along with j cap, that is 3 square, plus 4 square. Okay, it is coming about root 29. Okay, now if we have one vector whose magnitude is equal to 1, then we can call it as unit vector. Okay, if the magnitude is equal to 1, then we can call it as unit vector. So all this ij cap has got its magnitude equal to 1, that is simply mod I cap equal to 1, mod j cap equal to 1 and mod k cap is equal to 1. Okay. Also we can even write this I cap as x cap. It is also equal to x cap because it specifies that it is along, it is the unit vector along x direction, and also y cap which is along y direction and z cap that is along z direction, just like this p cap is along p direction, that means this is your p vector direction. Okay. So when I take a unit length, then it becomes p cap. Clear? Now how to find this vector p, the direction vector p? It is simple, like if I multiply this vector p divided by the magnitude of p, we get simply the direction vector p cap. Okay. So please make a note on all these three terms, the vector p and the magnitude of the vector p and the direction vector for the vector p. Okay. Now let's find out, or let's discuss now the vector addition and vector subtraction. Okay. Here I take two vectors, vector a and vector b. Now I have to add them up. It is simply a plus vector b is equal to, simply you add your I components, that is 1 I cap plus 3 I cap is 4 I cap, minus 2j plus minus 2j is minus 4j, plus 3k plus 1k is plus 4k cap. Fine. And if I need to subtract this, vector a minus vector b is equal to I minus 3i, that is minus 2i, minus 2 minus minus 2 which is 0, 3k minus 1k is simply 2k. So it is like minus 2i plus 2k. Now let's find out modulus of a plus b. It's just a practice problem. It is simply root of 4 square plus negative 4 the whole square plus 4 square, which is 4 root 3. Okay. Now vector a minus b is equal to root of minus 2 the whole square plus 2 square, it is simply 2 root 2. So these are not the unit vectors, okay, because we have the magnitude other than 1. Now let us see what is the unit vector along a plus b. How to get that? We have studied that, what was that? Unit vector p cap is equal to vector p divided by magnitude of vector p, isn't it? So here also similarly we will have the unit vector along a plus b is the same vector a plus b, our a plus b divided by the magnitude of a plus b. What's that? A plus b is 4i minus 4j plus 4k, and the magnitude of a plus b is 4 root 3. So when I divide individually, I get I by root 3 minus j by root 3 plus k cap by root 3. So this is your unit vector along a plus b. So next is vector multiplication. Let's take two vectors, vector a and b. So once when represented graphically, I can have like, let this be vector a and here comes your vector b, and definitely they will have one angular separation, that is theta. Okay. Now I can multiply these two vectors, okay, and there are two types of multiplication. One is scalar multiplication, another is vector multiplication. Scalar multiplication means when once multiplied, the product is a scalar quantity. That means our product will lax from ijk components. We will just have one single number or simply some variables. Okay, but vector multiplication means definitely the product will be a vector quantity or the result will be having ijk components. Okay, so these multiplication can be done in two methods. I mean, two classifications are there. When theta is given, see, when the angular separation is given, then scalar multiplication can be done like, we represent it like A dot B. Okay, A dot B is equal to magnitude of A into magnitude of B into cosine angle theta. And for vector multiplication, it is like vector A cross vector B is equal to magnitude of A into magnitude of B sine theta. Also, since I have said that the product is a vector quantity, we need a unit vector which indicates the direction of the result, isn't it? So, we represent it with n cap, and n cap is the direction vector of A cross B. Okay. Now, as the indication says, see here it is A dot B, isn't it? So, we call the scalar multiplication as dot product also, dot product, and vector multiplication, the symbol here is cross. So, it is simply cross product. Fine. Next category is when theta is not given. See, when theta is not given, how to multiply these two vectors. Okay. So, it is like A dot B equal to, you just need to multiply the coefficients of I cap, that is 1 and 3 here. So, 1 into 3 plus coefficients of j cap is negative 2 and negative 2. So, negative 2 into negative 2 plus coefficients of k cap is 3 into 1. So, it is simply 3 plus 4 plus 3, that is 10. So, 10, see, you can see it is simple scalar number, isn't it? It is a simple number which indicates that it is a scalar product. And for vector multiplication, when theta is not given, what you need to do is A cross B is equal to, you have to take the determinant of a 3 by 3 matrix, and the 3 by 3 matrix first row is simply I, J, K, and the second row are the components of A cap, I mean A vector A, that is 1, minus 2, 3, and the third row is the coefficients or the components of vector B, that is 3, minus 2 and 1. You need to just take the determinant of this matrix, and how to take it? It is first row, first column, that is I cap into minus 2, just cross it, minus 2 minus 2 into 3. Minus j cap into 1 into 1, 1 minus 3 into 3, 9, plus k cap into 1 into negative 2 minus 2 into 3 is minus 6. So, the value is 6 minus 2, 4 I cap, 1 minus 9 is negative 8, along with this negative it becomes 8 j cap plus 4 k cap is your answer. See, A cross B has turned to a vector product, vector quantity. Okay, that's all about vector multiplication. Now, here comes a beautiful operator, that is del operator. See, we have many operators in mathematics like plus operator, minus operator, into, division, etc. Similar to that, it is another operator del, but it has a wide meaning in many areas. Okay, let's see to it. Simply, just let me say you that you can write something, I mean x into 3 is x plus x, isn't it? So, if I write dash into 3, it is dash plus dash plus dash. Similarly, we can have the definition for del operator as del is equal to I cap into dou by dou x plus j cap into dou by dou y plus k cap into dou by dou z. Now, dou by dou x, dou by dou y, dou by dou z are partial derivatives. I will explain shortly. Now, what is actually this operator is incomplete unless I multiply any function over here. If I put phi over here, then it becomes I dou by dou x of phi plus j dou by dou y of phi plus k dou by dou z of phi. Similar to this, we know that this sentence, this mathematical expression is incomplete unless I add some number over here, similar to this. If I add y here, then y into 3 is y plus y plus y. Similarly, this del operator is defined like I dou by dou x plus j dou by dou y plus k dou by dou z. Okay, I will give an example. Let us take phi as a function in x, y and z. Let us take phi is equal to simply x square yz. Okay. Now, how to determine this del phi? Del phi is equal to I dou by dou x of, copy this phi over to here, x square yz plus j dou by dou y of x square yz plus k dou by dou z of x square yz. Now, how to take the partial derivatives? It is simple as your normal differentiation, just need to have some constants extra. Like if you are going to differentiate this function with respect to x, then the other variables, I mean the variables other than x becomes simple constants. So, when I differentiate with respect to x, then y and z becomes my constant. So, I cap into yz are mere constants, so can be taken outside. Now, dou by dou x of x square is 2x. Clear? Plus j times, I mean j cap into dou by dou y of x square yz. Now, what are the variables other than y here? X and z, isn't it? So, x and z are mere constants that can be taken outside x square z. Now, dou by dou y of y is simply 1. Lastly, k cap into dou by dou z of x square yz, isn't it? So, x square and y are the constants. Now, dou by dou z into z or dou by dou z of z is 1. So, your answer is 2x yz I cap plus x square z j cap plus x square y k cap. And now you can notice that our del phi is appearing to be a vector quantity. Okay. So, phi is a scalar quantity, and once we took del operator for that scalar quantity, see, this is a scalar quantity because it lacks I, j and k, isn't it? So, this is a scalar quantity. Once when taken a del operator for that scalar quantity, we get a vector quantity. Now, what does this del phi indicates? That is, if I draw a function with respect to x axis alone, for time being I am drawing with respect to x axis alone, so let it be phi of x, and if the function is like, just by looking at it, you can say that the highest point of this function is over here, isn't it? And if I draw a vector normal to that particular surface, then I can tell that this vector is called del phi. Okay, so del phi is the vector that points the maximum of your function. Clear? Next, this del operator can be applied to both scalar and vector. For scalar, we call it as gradient, like previous example was a scalar, right? That is del phi. Phi which we took earlier was a scalar. Then altogether, that is del phi is collectively known as gradient. Okay, and it has got another terms also, direction derivative or normal vector. Okay, direction derivative of phi means it is simply del phi itself. Also, normal vector to the surface phi means it is also simply del phi. Got it? And again, del can be applied to vector also. There we will have two multiplication, just like dot product and cross product. We can have two operators for vector quantity, that is divergence. Divergence means it is del dot, here we have to deal with a vector, isn't it? So, let it be vector A. So, del dot A means it is divergence of A. Let us say, for example, if A is an electric field, you know that plus charge will give away the flux lines like this, isn't it? So, by taking the divergence of this electric field, we can get how much quantitatively the flux lines have emerged or flux lines have diverged out. So, this is the dot product, that is del dot A. And next we can have a cross product also, which is known as curl, or it is del cross A. Okay, del cross A is also known as curl of a vector, and it says that, say for example, if we have a magnetic field lines B, magnetic field lines, that field lines will have a circular path which do not intersect, isn't it? So here some curling is happening. So del cross B, here for example, del cross B indicates that how much quantitatively the field lines have curled upon a surface, that is curl A. So I think I will give you a much more clear and detailed description on divergence and curl in my next video. So let's stop it for now, and I hope I could give you some idea about this del operator, vector calculus basics, dot product, cross product, etc. So if you like the video, please do like, share and subscribe it. If you got any doubts, please do post down below. So till we meet in the next class, this is Meenu signing off. Thank you and take care.